there is a certain distance from the center inside of which nothing can escape. It's the ultimate prison. Even if you move at the speed of light, you cannot escape from that region. So a black hole is just like Vegas. Whatever happens there stays there.
Okay.
But you can also make a black hole by...
You are interested in the nearest black hole to Earth.
Right.
Can you tell us a little bit about that and start with what exactly is a black hole?
So a black hole was the first solution to Einstein's equations of gravity. That back then, in 1915, there were no computers. And the equations are very complex. But a German physicist named Karl Schwarzschild, he was 40 years old, the head of the Potsdam Observatory. And he was a patriot, by the way. Einstein was a pacifist. So the First World War started, and Schwarzschild, who was very distinguished, was drafted to the military, went to the front against the Russians. And when he was there, he realized that he can solve Einstein's equations for a point mass. If you take matter and condense it to a point, he could solve the space-time around that. And he sent a postcard to Einstein, who publicized it in Germany, because he didn't participate in the war. And within a few months after that, Schwarzschild died from a rare lung disease, which shows you that being a pacifist is better if you want to derive the consequences of a theory, because Einstein lived much longer. At any event, Schwarzschild is remembered for finding the structure of space-time around a black hole. Now, what does it mean? How can you make such a point mass? One way to think of it is, imagine a star, a very massive star, let's say tens of times the mass of the sun, burning nuclear fuel. A star is just a nuclear reactor held together by gravity. That's it.
Okay.
So, we have a difficult time creating fusion reactors on Earth because confining them is difficult with magnetic fields. But in nature, they appear everywhere. These are the stars. They are confined by gravity. And at the core of a star, the temperature is tens of millions of degrees. And so that nuclear reactor burns the fuel, which is mainly hydrogen left over from the Big Bang. By the way, it was not clear to people that the sun is made mostly of hydrogen. So 100 years ago, the first PhD in astronomy at Harvard University was written by Cecilia Payne-Kopashkin. And she realized that when looking at the surface of the sun, she can infer the composition of the surface and realize that it's mostly probably hydrogen. And she wrote it in her thesis, and then the chair of the thesis committee, Henry Norris Russell, who was the director of the Princeton University Observatory, said, you need to remove that statement because we all know that the sun is made of the same materials as Earth. She removed it. Of course, she wasn't as confident at a young age. And then for 4 years, he checked the data and concluded that she was right. And it's not only the sun, but the entire universe is mostly hydrogen, the ordinary matter. That at any event, stars burn hydrogen into heavier elements. That's why we exist, because the Big Bang didn't have heavy elements. It had mostly hydrogen and helium. So life, as we know it, was not possible. We are a byproduct. We were not part of the cosmic plan. By the way, this is something we need to remember, that We arrived late in cosmic history. We arrived late to the play. We are not at the center of stage. So the play is not about us. And if we want to learn more about the cosmic play, we better find other actors who may have been around for longer than us. Mm-hmm. But coming back to the stars, they burn hydrogen and produce the energy that we see coming out of stars. Now, when a star has more than tens of times the mass of the sun, it has such a strong gravity that when the fuel is consumed, there is no more fuel. Gravity pulls it together and it cannot stop the collapse, and it ends up draining all the mass that made the star into a black hole at the center. So that's one way to make black holes, by massive stars collapsing. Now you ask, okay, what is the final product, the black hole that you get from that? It's empty space because all the mass went to the center, so to speak. But it's an extreme structure of space and time, because Schwarzschild realized if the black hole is not spinning, that there is a certain distance from the center inside of which nothing can escape. It's the ultimate prison. Even if you move at the speed of light, you cannot escape from that region. So think of a black hole as the ultimate prison. And the walls of that prison cell is the so-called event horizon, inside of which everything is hidden. So a black hole is just like Vegas. Whatever happens there stays there.
Okay.
But you can also make a black hole by taking a big cloud of gas and letting it collapse. That's what happens at the centers of galaxies. So just to give you a sense, if you were to fill the orbit of Jupiter around the sun with water, a huge swimming pool, it will make a black hole of about 100 million times the mass of the sun. So the bigger the black hole is, the less dense is the material that can make it. When a star makes a black hole, the density of matter gets higher than the density of an atomic nucleus. But when you make those supermassive black holes at the centers of galaxies, you can make them out of rarefied gas clouds that just contract. Okay. And once you have the seed black hole, it keeps collecting more and more gas from it, just like a drain, that water circles into. The gas in the center of a galaxy is getting consumed by the sink at the center. And you can also have stars. If a star comes close to a black hole that is not too massive, then it will get ripped apart and shredded. And you spaghettify the star, create spaghetti out of it, and the stream of gas. We see those events where stars are getting destroyed by coming close to a black hole that has a mass less than 100 million times the mass of the sun. So that's in a nutshell.
You've actually seen stars be consumed by black holes.
Yes, stars like the sun coming too close to a black hole of less than 100 million times the mass of the sun, and they get ripped apart. And before they enter the event horizon. So then the gas that they leave behind in a stream of debris circles the black hole and creates a flare of radiation. The amazing thing about black holes, even though they are black in the sense that nothing can escape from the inside, when gas is circling the black hole, it's moving at a very high speed, approaching the speed of light. And if the stream of gas intersects itself, or if there is turbulence or viscosity to the gas, then it shines very brightly. So ironically, the brightest sources of light in the universe are actually those supermassive black holes that we see now with the Webb telescope. all the way back in time to when the universe was just a few % of its present age.
Wow.
So these big black holes form very early. And I actually worked out a theory that that could explain early formation of those seeds out of very massive stars that form at the centers of galaxies.
Can you see both sides of a black hole? Or is it just one?
Well, it's just a spherical region. You can go around it.
Is it shaped like a donut?
No, it's more like a sphere if it's not spinning.
Okay.
If it's spinning, then it looks like a disk. But the interesting question that has no answer at the moment is what happens to the matter that falls into a black hole, because Einstein's theory of gravity predicts that it will increase its density, again, indefinitely, just like in the Big Bang, and then the theory breaks down because it can't really tell us what happens. You need a theory that unifies quantum mechanics and gravity to tell us what happens at the center of a black hole. And, you know, I once had a flood in the basement of my home, and I went with a plumber down to the basement, and I realized, actually, you know, I never thought about this. It would appear natural to me that the water is flowing out of my home, but we realized that actually there is, the sewer is clogged by tree roots, okay? And the roots were blocking the sewer, and so the water flooded the basement. So that, in the hours that I was helping the plumber to fix the problem, I thought about a black hole. What happens if there is no portal or sink at the center of a black hole? Because some people say, well, maybe the matter goes there and then exits somewhere else. But no, suppose it's really clogged. So what will happen is that the matter will collect at the maximum density that matter can have, which physicists call the Planck density. So the way I envision that is maybe there is an extremely dense object at the center of a black hole, and it keeps collecting matter that falls into it. We don't know if that is the reality because we don't have a theory of quantum gravity. And there is one way to find out. If you enter a black hole, you might find what happens inside of it, but then you won't be able to submit a paper for publication on Earth because no information can come out. So, you know, when I propose to physicists to enter a black hole and figure out quantum gravity, they think that I have an ulterior motive of sending them into a black hole. But, you know, you may ask, okay, are we at risk that a black hole would ever impact Earth and consume it? Turns out that the nearest black hole to Earth is about 100 light years away, based on how many we expect in the Milky Way galaxy. Not very close to us. There is no risk that it will cross the solar system. But there is a possibility that most of the matter in the universe is black holes. We don't know what most of the matter in the universe is. About 84% of the matter is invisible to us. We call it dark matter. Mm-hmm. You know, we keep saying that we understand the universe, but we don't know most of the matter, and we don't know most of the energy, which is in the form of dark energy or the cosmological constant that I mentioned before. So the dark matter could potentially be tiny black holes left over from the Big Bang that have the masses of asteroids, for example. And if that's the case, there should be many of them crossing the solar system. But the chance of one of them passing through Earth is really small. You wouldn't expect that very often, maybe over billions of years. And in fact, these black holes have a size, their event horizon is the size of an atomic nucleus. So really tiny. Unless they go through your body, nothing bad will happen. They just go through Earth, they don't affect anything. So maybe the nearest black hole is much closer than we anticipate based on the collapse of stars, you know, which is the 100 light years that I mentioned before. But it will be harmless unless they pass through your body. And the chance for that is completely negligible. I don't think that any insurance companies need to worry about it.
No matter where you're watching Shawn Ryan Show from, if you get anything out of this, please like, comment, subscribe, and most importantly, share this everywhere you possibly can. And if you're feeling extra generous, please leave us a review on Apple and Spotify podcasts.